Good morning, grade 10s. Welcome to your third lesson of exponents on our online lessons. Today we're doing addition and subtraction with variable exponents, and today's date is the 15th of the 4th. Okay, just remembering that a variable exponent has a base with a variable in the exponent. Also remembering with this, we often need to write our bases as products of prime factors. So for example, if I had 16, a product of its prime factor would be 2 to the power of 4. Okay, the difference from yesterday we did multiplication and division. So if I was multiplying, so for example, if I had 2 to the power of n times 2 to the power of 3, okay, over 2 to the power of 2n times 2, for example, what do I have here? I've got a monomial over a monomial, which means I can cancel immediately things that looked exactly the same. So for example, if I had 2 to the power of n times 2 to the power of 2n, what would happen? I would subtract. Where would the subtraction happen? It would happen at the bottom. And I'd have minus n at the bottom, okay? And then likewise with a 3, the subtraction would happen at the top, and I could cancel. With today's lesson, however, when we've got addition and subtraction, if we just take our very first example and the difference, so example 1, it says simplify 4 times 3 to the power of 2x minus 9 times 3 to the power of 2x minus 2 all over 3 to the power of 2x minus 3 to the power of 2x minus 1. That's our very first example, okay? So now I don't have a monomial over a monomial. I've got a binomial over binomial, or just a trinomial. So I've got a polynomial. I've got a polynomial over a polynomial, which means I cannot cancel things even if they look exactly the same. When we did factorizing, what did we say? How do we move from a polynomial to a monomial? What is this process called? This process is called factorization. Okay, so I have to make the numerator and the denominator into a monomial through using factorization. But I'm still going to use ideas that we used yesterday to do this. So let's look at example 1. Right, I'm going to write things as products of their prime factors, I don't really have to rewrite 4 as anything, but let's do it regardless. I've got 2 squared. That is my 4. 3 doesn't change. Times 3 to the power of 2x minus, rewriting 9 as 3 squared times 3 to the power of 2x minus 2. All over at the bottom, I've got 3 to the power of 2x minus 3 to the power of 2x minus 1. Okay, so what do I notice? I notice here that I'm multiplying two like bases. So what can I do when I'm multiplying like bases? I add the powers. Here's not like bases, can't add here. And perhaps here I'm just going to remind you that, remember, this has a 3 to the power of negative 1. Okay, so I'm keeping this as 2 squared times 3 to the power of 2x minus, keep the base, add the powers. So I've got 2x, because there's no like terms. My like term comes here with 2 minus 2. And what's 2 minus 2? It's 0. So I'm just left with 3 to the power of 2x. All over at the bottom, I've got 3 to the power of 2x minus 3 to the power of 2x times 3 to the negative 1. Okie dokie, what can I see? How do I move this from a polynomial to a monomial? Well, I start with my levels of factorization. The first thing I look for is an HCF. And yes, indeed, they both have 3 to the power of 2x. So I take out 3 to the power of 2x from both of these terms. So when I take out 3 to the power of 2x there, I'm left with 2 to the power of 2 minus, when I take out 3 to the power of 2x there, remember I'm dividing it. So what's 3 to the power of 2x divided by 3 to the power of 2x? It's 1, not 0. All over. At the bottom, I've also got an HCF of 3 to the power of 2x. So I've got 3 to the power of 2x. And what am I left with? 1 minus 3 to the negative 1. And now, folks, I've got a monomial over a monomial, which means I can cancel things that look exactly the same. What are the things that look exactly the same? The 3 to the power of 2x. Okay, so I've got 2 to the power of 2 minus 1, so that's 4 minus 1. You see how it wasn't relevant to change it? I'm just going back to saying 4 minus 1, which is 3, and I've got 3 divided by 1 minus 3 to the negative 1. Okay, let's put this into our, let's put our algebra skills to work, or our, I'm not going to put that into my calculator. I want to show you how it works. Okay, so how do I work with 3 divided by 1 minus 3 to the negative 1? Just rewritten this there, and I've written it in one straight line. Well, how do I work out this bracket first? How do I get rid of the negative power? I move it to the bottom, 1 over 3. So I end up with 3 divided by 3 over 3 minus a third. We know the rules of fractions. Make the denominators the same, so I change that to 3 over 3. And all of a sudden I've got 3 divided by 2 over 3. We know the rules of fractions when I'm dividing, tip and times. So 3 times 3 over 2. And what am I left with? 9 over 2. That's my answer for example 1. Okay, so this part is lots of steps, so very few marks, but it is important that you know how to do this. Let's look at example 2. And example 2 looks like this. It says 5 to the power of x minus 1 times 11 minus 5 to the power of x plus 1 all over 5 to the power of x plus 5 to the power of x minus 1. Okay, polynomial over polynomial. There are 2 terms here. Look at the division, and there are 2 terms here. So please, you cannot go and cancel that with that, because I don't have a monomial over a monomial. I have to move it to a monomial over a monomial, and you know how I do that? I do that by factorizing. Okay, bearing in mind that this has a 5 over there, 5 to the power of negative 1, and this is a 5 over there, 5 to the power of 1, and here's a 5 to the power of negative 1 there too. Okay, at the top, can you see what I have? I've got like terms, 5 to the power of x and 5 to the power of x. So I'm going to factorize by taking out an HCF. And what am I left with? 5 to the power of negative 1 times 11 minus 5 to the power of 1. All over at the bottom, take out an HCF of 5 to the power of x, and I'm left with 1 plus 5 to the negative 1. Cool. Monomial over monomial, which means I can cancel things that look exactly the same. That and that can cancel. Okay. What does this look like? 5 to the power of negative 1 times 11. I'm going to write out all the steps so you can see. This becomes 1 over 5 times 11 minus 5. Okay, all over 1 plus 1 over 5. Okay, change that to a power, positive power, change that to a positive power. So I'm left with, and I'm going to write it out linearly, so there's my division sign. So on this side, I've got 11 over 5 minus 5 divided by 5 over 5 plus 1 over 5. Skipping a few steps in between. I hope you can keep up. Here I multiplied and I got that out. Okay, and let's just actually immediately change this 5 over 5 to 25 over 5. Sorry, not change the 5 over 5, change the 5 to 25 over 5. That's what happens when you talk too fast. Why do I do that? Because I'm subtracting, so I need the same denominators. So then I just say 11 minus 25, and I get negative 14 over 5 divided by 6 over 5. Okay, I know my rules for division. Coming right up to the top. Okay, I'm just rewriting this as negative 14 over 5 times, tip and times, 5 over 6. monomial over monomial, so I can cancel. Those things cancel, and I'm left with negative 14 over 6. Simplifying negative 14 over 6 is negative 7 over 3. Okay, if you want to write it as a mixed number, you can, which is, I don't struggle, but I don't enjoy it, negative 2 and 1 over 3 is a mixed number. But getting right there is fine. Please, you have to simplify that further. Okay, and then we're doing the last example. And the last example is example 3. Example 3. It says 3 to the power of x plus 1 minus 3 to the power of x plus 2 over 3 to the power of x plus 3 to the power of x plus 2. I wonder if you can see it already. The 3 to the power of x's are going to cancel because I'm going to take them out as an HCF, and I'm going to be left with the various bases. Okay, remembering that this has, not a 2, a 3 to the power of 1. This is a 3 to the power of 2, and that's a 3 to the power of 2. So, what do I do at the top? Polynomial of a polynomial, I must make it a monomial. I do that by factorizing. I take out my HCF of 3 to the power of x. And what am I left with? 3 to the power of 1 minus 3 to the power of 2. All over, take out my HCF of 3 to the power of x, and I'm left with 1 plus 3 to the power of 2. Monomial over a monomial, which means I can cancel immediately. What can I cancel? My 3 to the power of x's, they cancel. And what am I left with? Please, you can't cancel these two things now. Why not? Because once I've cancelled this, 3 minus 3 to the power of 2 over 1 plus 3 to the power of 2. This is again a polynomial over a polynomial. So I cannot just cancel those two things off, okay? I'm rather instead going to work them out. So I've got 3 minus 9, and that gives me negative 6. So here I have negative 6 divided by 1 plus 9, which is 10. Simplifying that, I get negative 3 over 5. And that is my answer. That one's actually quite an easy one. There is an example 4 on your worksheet, but example 4 is exactly the same as example 1. So regardless, you then have exercise 3, and there are a number of questions on there, and you can do all the questions. Okay. I just thought of something that I didn't show you yesterday, and I'm pulling this example out of my head, so please bear with me if it doesn't work out. But if I had, and it was based on that question I just did earlier, 2 to the power of n times 3 to the power of 4 over 2 to the power of 2n times 3 to the power of 2. Okay. Right, please remember that this 3 to the power of 2 to the power of 2n. How can I write this? Remember, this is 2 to the power of n times 2 to the power of n. Because I get 2 to the power of n plus n, which is 2 to the power of 2n. Okay? This is not 2 to the power of 2 times 2 to the power of n. Okay? Because that gives me keep the base, add the powers. So please bear this in mind, that 2 to the power of n means I've taken 2n times 2n. Okay. Why is this important? Because what happens if I give you this? It's easy to see with the 3's. This must move up and the subtraction happens there. What happens with this? I've got 1n and 2n. So where does my subtraction because of the division happen? It happens at the bottom. This becomes negative n. So my answer to something like this would be 3 to the power of 2 over 2 to the power of n. Okay, because 2n minus 1n is n. Why does this work? Because if I had 2 to the power of n over 2 to the power of 2n, which we've discussed is 2n times 2n, monomial over monomial, right? So I can cancel things that look exactly the same. That and that cancel. And what am I left with? 1 over 2 to the power of n, which is where I got my 2 to the power of n at the bottom. Okay, I didn't show you this yesterday, but it's quite important to keep it in mind, perhaps, when you move the variables up and down. Okay, anyway, grade 10s, good luck with your exercise. The memo will be put up later on the Instagram page. Sorry, grade 10s, the question in your paper is different to the one I did on the video. I said minus and it's supposed to be plus, so this is just the correction. It doesn't change the working out. The part at the top here, the only time it changes is here where I added the fractions. The fraction should be 6/5, and then when I tip in times, the final answer is 6. So I am very sorry about that, but this is the correct answer for this specific example with the plus.